Alright, so today is 10-9, sections 3.3, and this section is about solving equations with variables on both sides.
Fun. Is this hard?
Okay. So when you have variables on both sides, so far you've been working with equations with variables on one side, but today we'll be doing this. So your goals for today.
Weren't there some of these on the homework? Like 2 of them?
Maybe.
I don't think so.
I think they were.
There we go. So your goal for today is to solve equations with variables on both sides. That's one goal. So when you're done by today, this assignment, you should be able to do these on both sides. And then second goal is to identify equations that are identities or have no solutions. Okay, so those are your 2 goals today. And it looks so blurry.
Yeah. Oh, yes. Why is it so blurry today?
I don't know.
Your camera's kind of messed up. It's kind of like that basketball player.
Yeah.
Turn it down.
I literally can't.
Okay, maybe I'll wear with my ink. Here we go. So, we're going to do example number 1. We're going to do the first goal today. So this example, so it's going to ask you to find value of x. Now, remember, algebra doesn't stop here. You will use algebra in geometry. So in geometry, you have 2 lines that intersect like this to create angles. These angles are called vertical angles.
Do we need to write this?
You need to draw this. Now, my last 3 hours told me they heard of the word vertical angles. Have you heard of it? Hmm? You don't remember? Okay, vertical angles, if you notice,
Yeah, I remember.
the angles that are opposite from each other, so these are vertical and these are vertical, okay? Vertical angles are congruent. That means they're equal. Vertical angles are congruent, okay? So when I give you the angle measures here, this angle measures 5x minus 3. And this measure is 2x plus 12 degrees. I could solve for x that would make these 2 angles equal each other. Okay? So, because vertical angles are congruent, I could set them equal to each other because they're equal. So, my equation would be 5x minus 3 is equal to 2x plus 12. Okay? And I spelled vertical angles wrong. This is A-L.
This single
Yeah.
answer, can you tell me it's right?
Excuse me?
Can I go through
No,
it?
not yet. All right, so if you notice, we have variables on both sides. Right? So, step 1. Bring all variables to one side. But to go from one side of the equal sign to the other side, you have to do the opposite. Okay? So, what I like to do is take the smaller x value and bring it over to the bigger x side, right? So to bring this over to this side, you do the opposite of positive 2x. So minus 2x. Minus 2x. Bring it over to the other side. This makes it 0. Now it's gone from this side, right? So this side would be 3x minus 3 is equal to 0 plus 12 is 12. Now all the variables are on the other side. All right? So then step 2 is to bring all numbers to the opposite side. Okay, so like this is just this two-step equation, right? What we've been doing so far.
Yeah.
So now I'm going to bring the 3 over, so I'm going to add 3, because you do the opposite. So then this becomes 3x is equal to 15. And then the last step would be to divide by 3, so x is equal to 5. Okay? So when you have two variables on opposite sides, bring all the variables to the one side and take all the numbers to the opposite side. Okay?
Keep that up there.
Yep. Now, once you get your answer, now we're going to check. Is this x going to make this angle
Yeah.
equal to this angle?
Yeah, you just plug it in, right?
We're just plugging it in, exactly. So here it is. Write down your original problem. Now we're going to take this x and plug it in here and in here. So we're checking. So we got 5 times 5 minus 3 is equal to 2 times 5 plus 12. Is this side going to equal this side? Well, 5 times 5 is 25, minus 3 is 22. 2 times 5 is 10. 10 plus 12 is 22. So because they're equal, it checks. That's how you check your answer. Okay? Now, listen. If the problem asks you to check, please check. Okay? So this is how you
So if it says don't check, we don't have to.
If it doesn't say anything, you do not have to. But I would recommend checking.
Anyway.
Okay? Any questions with this? So this is variables on both sides. Now you guys try this one. Ready? Try this one. Here we go. (2.5) x plus 1 is equal to 4x minus 2.6.
Wait, 2.5x.
2.5x plus 1 equals 4x minus 2.6. So you guys try this.
Directly from the book?
No, go sit.
But then get some hand sanitizer.
Drake.
Does it matter which one you first? I would always take care of the variables. Yeah, but like, it doesn't matter which one.
It's not wrong whether you take it to the other side or not.
So if it's,
I like to always bring the smaller one to the bigger side.
So bring this out. So,
Yeah, because I don't want any negative ones. I don't want to take
track.
but if you do, you have to do it on both sides, right? If you do it-
Always on the both sides, and don't drop your x. You're not bringing just the 2.5, you're bringing all the 2.5x.
I know.
So
So
the
4
x-
minus 2.5 is 2.5.
You got it wrong.
1.
2.5 is 2.5.
No, 4 minus
what you're
And it'd be
saying.
1, this class would be 1.5x. Minus, you still think that is right? 1 equals 1.5 minus 2.6.
Wait, so then what do you
2.6.
do?
Now bring the other numbers to the other.
So not x, then it's
Minus.
This whole thing goes like that, so there's no x.
So it's minus 2.
No, what's opposite subtracting? Wait,
Add 2.
add so that's this?
Add 2.6. You got it?
3.6 equals. So that's your answer.
Where? Are we improving root mean?
You gotta line up with that.
No, it's this one's always now.
Oh, you did. Oh, I'm sorry. So then
What's the answer? Does anyone have it?
How do you,
got
how do you know what, like,
Okay.
can't leave it like that.
All right, now, can I suggest? Now, it's not wrong if you bring the 4x to this side. It is not wrong. You could bring it to either side. Only reason why I don't bring it to I don't bring the 4x because I don't want a negative x value. Okay, that's the only reason why. All right. So, did you guys? I know that Tyler got rid of decimals. Anybody else got rid of decimals? Okay, so we're gonna stick with decimals. All right. So I'm gonna subtract 2.5x. Did you guys do that?
Yeah.
Okay. So minus 2.5. That means you have to add a 0.0x. Shh. Please check. So then this becomes 0. 0 plus 1 is 1 is equal to, I got to borrow, so this will be 1.5x minus 2.6. Now I have all the variables on one side. Now I got to take all the numbers to the opposite side. So I'm going to add 2.6 to the other side. Okay? So then this will be 0. So now I got 3.6 is equal to 1.5x. And then divide by 1.5. Please use this division sign, please. A lot of you guys are not doing that yet. So this becomes 1. 1 times x is x. And remember, you're not allowed to have decimals in the denominator, so move the decimal over 1. So now it becomes 36 over 15. Now, can I reduce?
Yeah.
What could go into both 36 and 15? 3. 3 goes into 36 how many times?
Over 5.
Over
5.
5. There you go. That's your answer.
Can you leave it?
Okay? Leave it like this, please.
Can you leave it as 36 over 15?
Yeah, you could leave it like that. That's fine too. That's not wrong. Okay? But if you can reduce, please reduce. Questions?
Oh,
How did you get 2.5 turn to 1.5?
2.5 into 1.5. 4 minus 2.5
Oh, it is. Oh, yeah.
is 1.5. Okay? All right. So everybody understand how to deal with equations with variables on both sides. Okay, so that was our goal number 1. Now here's goal number 2. Identifying, right here, identifying equations that are identities or have no solutions. All right? So here's our last example.
Oh, sweet.
Just sweet Mary.
Just sweet up.
We're going to solve. Are we ready?
Too late to fat Michigan.
Shh. Here we go. Here's first one. I got 4 minus 4y is equal to negative 2 times 2y minus 2. What's my first step? Distribute, right? So I'm going to multiply negative 2 into both. So this becomes 4 minus 4y is equal to negative 2 times 2y is negative 4y. And negative 2 times a negative, right, that minus makes it a plus 4. Now we got variables on both sides, so I'm going to bring all my variables to the left.
You want to get rid of the negative.
So
first.
plus 4y, plus 4y.
Identity. It works.
These cancels out. 4 minus 0 is 4. And that is also, these also cancels out.
Identity.
4 equals 4, right?
Wait.
That means this side is identical to the other side.
Identity.
This is called an identity. Do you know what that means when it says identity?
It keeps the same number.
identical.
I know,
What
but
it means identical.
what this means is you have infinite solutions. That's what that means. So if one side is identical to the other side, it means no matter what value of y you plug it in, it's always going to equal. So the way this translates into later chapters when we're dealing with linear functions, that means that these two lines are exactly the same line. Okay? So does everybody understand what makes it an identity? Okay, so then here's the second one. Negative 6x plus 8 is equal to x plus 10 minus 7x.
Group, put together the x's, x minus 7x equals negative 6x.
There's Jackson. Ready?
Yeah.
Jackson says combine like terms. So you get 6x plus 8 equals, now these are your like terms. So I got 10, x minus 7x is negative 6x.
And that's 8 equals 10, which doesn't match, so there's no solution. 'Cause you
Add
added
6x to both sides.
Jackson, were you in algebra last year?
No,
0 plus 8 is 8.
I'm just, have
Did we
common
actually?
sense.
You're not wrong. Oh, no.
Does
solution.
8 equal 10?
I'm not wrong.
No. So since 8 does not equal, this says no solution.
Not you.
Okay? Excuse me.
Did it again.
You have to say no solution. Listen. That means that no matter what x value you plug in, this side will never equal that side.
You did it again. You put the I over the
I don't care.
Why do you do that?
Does everybody understand?
Why do that?
Okay. All right, go to your assignment section, please.
I'm already finished with my paper, though.
Jackson, no, you
I did my math.
stole my algebra book and did my math. Fat stack.
What? I'm done. I went to today's work already.
Wait, I didn't.
You weren't even in the class.
Yeah, but I looked at it.
It's on Classroom.
I didn't even
No,
post it.
someone at my lunch told me what it was, and if I knew how to do it, there's no point in like not doing it.
Jackson, you looked on Classroom. It's on Classroom.
It's not on Classroom.
Since when? It's always on Classroom for me.
After school.
Plan book.
And then 18 through 28 evens. See, I knew that.
You know what? Let's change that to 17 through 27 odds.
Serious.
Can you get the problems from other people?
Yeah, I think I'm gonna start changing it up.